Okay, I have been doing coding challenges all day, and actually it's been working out better than I thought it would. I'm like kind of suspicious, but this is actually the last one I have prepared, and it actually comes from the HackerRank video here about. Actually, it's not this one. It's the 3 algorithm strategy, and it's mentioned somewhere here. Yeah, so like this is on HackerRank. They have, and I'll actually reference it. So it's on the HackerRank practice interview preparation kit tips and guidelines, and there's a video here called 3 algorithm strategies, and the person who's speaking is the person who wrote the book Cracking the Coding Interview, so she knows what she's talking about. And oh wow, there's like a lot of videos there. I could probably watch those. One thing she mentions is like her strategy for tackling algorithms in general. So this problem is kind of a semi-classical one, where it's a cubed plus b cubed equals c cubed plus d cubed. They need to be different numbers. She actually kind of talks about some solutions already, so I'm effectively kind of cheating with this one. But I thought I was really curious about like how I would go about solving this one. So I guess I'll put a timer on just because I've been doing it the whole time. So I'm going to start this off kind of arbitrarily at 15 minutes, but I've kind of been getting familiar with this problem for a little while now. Find all values a, b, c, d are integers between 1 and 1,000. So actually, I don't think I need a function for that. I just need to do just a for loop. I just need to like write it out. That's fine. For let a equal 1, and while a is less than or equal to 1,000, a plus plus. Okay, and I'm just gonna do. And I'm going to duplicate this a bunch of times. And this is going to be in this spot, in this spot, in this spot. This is going to be B, this is going to be C, and this is going to be D. And, oh, not like that. Okay. So get down, like that, and like that. And that is your basic for loop. And my solutions are here. And it looks something like if a time to the third power. How do you do that in Node? I think it's math.power. 2 to the third should be 8. Yeah, okay. Yep, done. Yoink. So math.pow a to the third plus b to the third equals c to the third plus d to the third. Now, if that's the case, then we will have solutions dot push. I kind of want to make it an object. I think that works. A is A, B, so that C, and D, D. All right, and that is my solution. And I can console.log solutions. Well, this will definitely work. This is currently a O of n to the 4th, n being 1,000, so that's really inefficient. But let's see if my computer can handle it. I think it probably could. Challenge A, B. Ooh, that's really loud. Ooh, oh, that's fine. Okay. JS not found. Correct. You need Node. Oh my goodness. Why are you so loud? Okay, it's taking a long time. It is suffering. My computer is not happy. So 1,000 to the... let's see here. To the third power. Oh, sorry, 4th power. Oh god. Oh my god. This is just the 3rd power. That's 1 trillion. Yeah. Okay, I'm gonna save my computer from dying, and make life a little bit easier. So one of the strategies that she mentioned, and I think I might have intuitively thought about this as well, once you have established a combination, so you do a times b, you know what works on the c and d. So you can store it in a hash map basically. So const, this is like c and d, c and d. I don't like the way this variable name, c and d. I don't like camel case either, but whatever. All right, like I would prefer camel case, but anyway, this will be storing cubed sums of c and d. Effectively, you have a lookup for a and b. So at this point, you have a times b, right? Or it looks like this. A, b. And you know what their sum is. So this is like sum. Constant, right? Okay. So you have their sum. You have a and b together, right? So you could, in theory, I kind of want to say if a, I really don't like the idea of them being the same. If a is not equal to b, that's the only time that this matters, in my opinion. Yeah, okay. So you get the sum, and then you store it in this thing here. So you say, hey, sum. If the sum is not existent, then we will store it there. Equal sum. You actually don't store the sum there. You store the AB. And now you come in with this. For C, you can now do. Actually, I think this is where I am doing C. So, sorry, this is here. So we have sum in there, and that's A plus that. And I want to also say, like, if A equals B, then we just continue, because we don't care about that situation. And we're in a similar position where we want, so AB can't be the same. We don't want A to equal C, or A to equal B, or B to equal C, or B to equal D. So if any of those things are the case, I want to continue. Otherwise, we get the sum of C and D. This is a right sum. This could be left sum. So right sum, and we are storing that in this here. So if you are not in this right sum, then guess what? We're going to store you as such. Sorry. Okay. Equals C and D. Right, C and B. C and D. Dirt. D. Here, okay. And that is the right sum, and that is good. And so you only get down here if you don't find it in the dictionary already. So else. So we're looking for left sum, which should match the right sum. So this is more of an if statement. So if left sum is there, then you get C equals, so CD. I don't want to use CD. I want to use underscore. Fine, underscore. This is a const. I think that'll work. That and that, and then just doing a little destructuring, and I can check this again here because this is the thing that I'm avoiding. Continue, else we do our check. Oh no, these work, right? Because this is where they are equal, and then that's what you add. You just add those three. Okay, so else solutions dot push AA BB, and this time it's C is underscore C and D is underscore D. I'm going to copy this because I also go down here. So I'm over time at this point, which is okay. I think I'm basically at the end of it anyway. Sum is that. So if you don't exist in there, then add yourself to it. And then you push solutions where if left sum equals right sum, do that. And this is C and not that. So you push up here, or if you found that the same thing already, is up here as well. So I don't know if this is actually going to work, but let's see. Missing initializer in constant declaration. Okay, so the way this works is let and like this. C is not defined. A equals C underscore C. That's D actually. Okay. D is not defined. Fantastic. And underscore D. Oh, come on. So it is. So it's gonna take a while. I think still, no matter what, it's still like n squared for the most part. But let's see how this works. Oh, that makes sense. Okay. Let me stop this here. Yeah, so this whole CD thing doesn't. Yeah, you don't need to do that again because you already know what the equality is here, because C and D have been effectively found already. So let me not. Yeah, that makes sense. I was curious about that. So the idea here is you don't need to loop through C and D because the multiplications of A and B have already been calculated. All right, so C and D is that, and so as long as okay, so you go through it, you get your left sum. A cannot be equal B, so actually I should do that first. Okay, so you get your left sum, and then you say, okay, if left sum exists, then we have our C and D effectively. And then we can make a comparison. Hey, as long as these things aren't equal, then we're fine. otherwise continue, else solutions push your solution. Because their sum already equals. And I think that's kind of it. So this helps reduce it. It's still, well, actually, so the 1,000, so getting down here is still, it's actually O of n, because this 1,000 is stored, right? So maybe it's like log of n, but it's still pretty good compared to what I was doing before. Hey, I got no solution. Fantastic. Can I print out? See that? Can I see what got stored? Because it must have stored something. It stored nothing. So something's up here. So as long as a is less than or equal to 1,000 plus plus, I'm not storing it. That's the thing. So cd left sum. Then you know what you're doing. Else, we need to actually store. I forgot to store the value, so that's a thing. Yoink. Else, we got A and B. Okay. I think now it should spend a little bit more time doing what it's doing. Good God. Okay, so don't do that. And I don't need to see this, which is interesting. Holy moly. That was so fast. Holy hell. 9 cubed. That's so cool. I'm very surprised it worked so quickly. That was like ridiculously quickly. So that took longer than I expected, but it's fine. I was really curious about like how this solution worked out. So, and also I'm including my own restriction here about like all the numbers not being the same, because you could just have like 1 cubed plus 1 cubed equals 1 cubed plus 1 cubed. It's like what information? Well, who cares? That's like inherently obvious. So so you're still doing n being the size at 1,000. So you're still doing n cubed, or sorry, n squared, but you're not doing n to the 4th. So that's like you're saving a lot of time, a ton of time, by storing these sums. This was actually not as hard as I thought it would be. You know, I thought like, oh, this like doing the naive solution it looked more complicated than it needed to be. Literally just storing everything in a hash map and saving yourself trouble is, as always, it seems to be like the better solution. So anyway, hope this was useful, and I'm actually going to do one more video that is kind of a fun video. So hopefully we can tackle that together, and I'll see you on that video.